Hi everyone, my name is Nicholas Mulder. I'm an engineer here at Furcal Electric, and today I would like to invite you to discuss a little bit of MDU fiber deployment and new ways to connect users. So it's not new to anyone that fiber is very important for us right now because it is what brings most of our high-speed internet. But what we not always know is a little bit of when it started in terms of FTTx, which is the most popular technology that we're using to provide fiber to the customers, right? So it launched around 1999 with a major program in Japan. And we from there evolved a lot. So in 2022, more than 30% of house passed in the world, which accounts for around 800 million households. So why it became so popular? So basically it is high bandwidth. So fiber surpassed the copper in terms of the ability to transmit data. Also, the cost starts to become lower with time. So fiber was very expensive in the beginning and now it is way cheaper. And the ability to have multi-services. So you can transmit video, you can transmit audio and data throughout the same mean of transportation, which is fiber. And the most important is with copper carriers, once installed the products and they had to replace it for fiber, and fiber now, especially on the passive optical technology, it is future proof. So the same installation that you're performing today, if it is well installed, will be able to sustain future applications. So thinking about all this fiber install, all this population, we still have a long way to go. But currently, most of our residential units are going to buildings. So, of course, we still have a larger number of single family units in the world, but we're seeing this change into the way people are living. So it is very usual to see vertical habitation, so buildings with a set of apartments in it. And that it is a trend because we're having more people in the world and land is becoming more expensive. So we have many constructions. And when we talk about buildings, usually we start to have a different types of buildings. So we have older buildings that were built a long time ago that didn't even think about infrastructure for telephone systems, that only thought about HFC cabling or copper cabling. And besides that, we had many operators going and installing fiber on those buildings. So everything starts to get messy. And the types of building varies a lot, not only when they were installed, but also what is the height. It is a vertical building. It is a more a horizontal type of building. How many apartments do you have? But one thing all those buildings have in common is that everybody wants to have fiber in their home and fast internet. So when a carrier starts to plan for a building, it has many options. So in terms of topologies that are available, and each topology has its pros and cons, you need to think of how you're going to install and distribute the fiber inside the building. So you can think of a more traditional approach where the splitters responsible for dividing your signal for the passive optical network are centralized, so they can be in the base of the building, and from the base of the building you will take a fiber to each and every apartment. You can think of a direct connection. So here we had a riser cable consolidating all the fibers into one cable. And here we have each single fiber going to each apartment. So if I have 12 apartments, I will have 12 individual cables living here. And then we have a distributed approach where we have the splitters on the floors. So these, we gain a little bit of advantage on the riser cable. So Dividing the signal closer to the users means you can use less fiber on the riser installation. You can decide to put all the splitters only on the floors, or you can go with a two-tier distributed splitter installation. So you put the splitter on your first box, like a 1x4 division, and then you go with these 4 fibers to each and every splitter on the rows. The decision of this topology, it varies depending on the carrier. It varies depending on the building. So for a smaller building, might be a better idea to put a smaller splitter on the base of the building and perform a direct connection. You may have enough space to do that. You may have the infrastructure ready. And for a building where you have less space available, if more users, you can use a double tier splitter type of installation where you can reach the users using less space. So as mentioned, one of the biggest difficulties that we have when installing building is the different types of building that we have, crowded infrastructure or no available infrastructure, and that can be from multiple carriers, different usages of the floor box, cables from legacy technology deployed. So you have a lot of space used, and it's not uncommon to have technicians go to perform the installation and see that there's not enough space, because depending on the type of installation that you are performing on the building, you might not be able to put your fiber box inside here or push your cable correctly throughout the network. So this is a little bit of what we're going in this evolution of network. So taking this into account on a traditional deployment where you have thick cables, multiple splices, and it's time consuming because the technician needs to access the building and stay there for a whole period, splicing things and passing multiple cables through, disrupting the residents. We got that feedback and we tried to look on how to have the smallest box as possible with a single fiber cable, so a small cable. So usually when we think about different types of installations, we can have a traditional deployment where everything is spliced. So you put a basement box and you put your splitter there, and from there you will and it takes a lot of effort and number of technicians to perform that. But we're talking about a smaller cost of material, smaller cost of complexity of the materials, because we're basically talking about a splicing solution. Then, to solve this problem, the quality of the labor, the time, we can have pre-connectorized solutions, pre-terminated solutions. So the solutions already starts on the factory with the cable has a connector on both ends. The job of the technician is basically plug and play on both sides. But for that, it still takes some time because you have to pass connectors throughout ducts. You don't always have this space. It is less dependent of the labor quality because once everything is pre-terminated, you don't depend the ability of the installer to perform a splice or to put a connector on the cable. But pre-terminated products tend to be more expensive than traditional deployments. Then we have the solution, the new way to connect users that we're talking here, which is the MDU Grow Solution. So it is basically taking the less complexity of the pre-connectorized solution and speeding time, but also balancing in terms of the products that you're using. So the idea here on the MDU is to have a single fiber cable going through distributed boxes that have splitters. So instead of having a 12 fiber riser cable, 24 riser cable, I have a 1 fiber riser cable that will feed the floor boxes. And these floor boxes will be able to provide service up to 8 customers. So what you have is again that you have the advantage and speed of a pre-connectorized or field assembly connection with a cable that has only one fiber, and this one fiber is interconnecting all the boxes. So you will gain time because you only have one fiber to connectorize. It is not labor dependent because you have pre-terminated products or pre-connectorized products that do not require splicing. And still, you're not using as many as products that you would be using in a fully pre-terminated solution. So what are the key points when installing something, a new solution? First, it is the performance of the network. So pre-terminated solutions tend to have a guaranteed performance. Then it is the installation time. How much time a technician takes to install a network. Faster the network is installed, faster the carrier can move to another building to install to another customer. And then it is the operation and maintenance. It doesn't mean anything if you send a technician to perform an installation and 2 other customers go out because something happened during the installation of the customer. So you need to be careful with the maintenance. How long does it take to replace a cable? Do you have splices machines available? And also training. Do you need specialized labor? Do you need to train new technicians? Because usually you have a high turnover rate. So we took everything in consideration. The difficulties of the building, so different architectures, brownfield buildings that are overcrowded. Then we had the different topologies that you can face, the availability of pre-terminated solutions, and how to make everything come together and make the connection easy. So this is the easy solution that we become, the MDU Grow Solution. So it takes advantage of unbalanced splitters inside the floor boxes that we have here. And we use a 1 fiber connector to interconnect the boxes in here. So you will get a small riser cable. This riser cable can be terminated in field connectors or pre-terminated connectors. And that is enough for you to reach floor boxes that are able to activate up to 8 users in here. So, but how does it work? How can I have a single fiber interconnecting a whole building? So this is a little bit related to our passive optical network solution. So passive optical networks take advantage of these splitters. So splitters usually, from the way we know, they divide the signal equally between the output ports of the splitter. But you can also have splitters that are not balanced. You can have a splitter that sends, for example, most of the signal to one side and a less amount of signal to the other side. And this works really well with pre-terminated solutions and GPON because GPON has a power budget that is very flexible. So the maximum amount of losses that you have in a GPON network is very large. So we're talking about minus 27 dB. We're talking about a lot of division losses. So to ensure a connection, you just need to reach the user with the correct amount of power. That can be achieved by taking only the needed power to the 1/8 splitter that will support the users, and all the rest of the power will go to the next box. So this is how you can have one fiber. So you have one fiber reaching the box. This box will have an output connector that goes to the next box, and part of the signal stay in the balanced splitter to activate the users. So taking a look into a more general topology, for example, what you have is a sequence of unbalanced splitters saying, for example, 30% of the signal goes to the users and reaches the user with enough power to activate, and 70% of the users goes to the next box. So most of the signal keeps on the network, but in each box, it leaves just enough signal to activate the users. So it is a smarter way to use your power budget and install everything. So basically, in terms of looking into what is the customer feedback that we have, is you have the traditional specialized labor that has more users, that has the use of splices machine, the use of larger cables and hard to pass, to a solution that you have less specialized labor. You can use half of the team to install. The cables are very lightweight and allow fast installation because we're talking about only one fiber. So the general output that we have from customers that it is using 50% less technicians and we have a faster installation rate. So talking about of the products of the solution, so we need to make a transition from your outside plant to the inside plant. So for this, we use this 12 fiber box. So this is our first box, our basement box. This box allows you to splice the cable coming from the street into the building. And this will make available that you can start your sequence of boxes. So from this box here, we will reach our sealed MDU box that will be responsible to provide signal to the users. So from that first box, we will reach with one fiber connector, and we will be able to activate the 8 users. So the cable that we recommend for the riser, it's called the micro indoor low friction. So this cable can be pushed through. So it has a low friction jacket, ideal for overcrowded environments, that you can install only by pushing it. And it is a very compact cable that it has 2 millimeters by 1.6 millimeters. And the main advantage is that this cable is fully compatible with field connectors. So these field connectors allow the technician to cut the cable on the right length, and without a splicing machine, without any sort of fusioner, you can perform the connection and still have a good loss amount in the connector. So as you can see here, without any splicing machine, our technician is opening the cable, cleaning and cleaving the fiber, and then putting the cable into the adapter of the connector. Once it is in the adapter, you can use the parts of the connector to proceed the installation using the provided accessories to install inside the cable, inside the connector. So now the fiber is cleaned, cleaved, and striped. Once the preparation of the cable is done, you can move to put the fiber inside the connector. And that's it. The connector is done. You're ready to activate the users. So this, we can reach our users with a drop cable, the easy connector, and the inline rosette. So here on the side of the user, it becomes a very compact installation with just a small cable going through the device. So basically, this is a new way to install fiber to reach our users. And I would like you all to consider a little bit on how we can explore a little bit more of the topologies and think of the use of unbalanced splitters to perform connections on the network. So thank you very much for watching. Hope you see you all on our next webinar session here. Thank you.